Stock battery, 6.4 volts, terrible. Get in the bin. Today we upgrade. Today we go 8.4 volts. Hobby grade battery pack, 3000 milliamp hours, paired with a brushed ESC. We are going to overvolt the crap out of this car and see just how fast it can go. Follow along for a complete rebuild of this car. We're going to put every single screw back into it. Everything has been taken apart. Let's see how this car goes back together and see how fast it can go on proper power. So you can see I've dremeled out the bottom of the chassis here. And this is the gearbox. Now what happened here is interesting. On the rear wheels, this is the rear drive hub. This slots in to here and spins the wheel via a hex. Great. The problem we have is that this drive shaft is a push fit system. So this piece of metal is only held in by the friction of a slight knurling on its surface. So what this means is when you put this through here and you put the nut on the other side and you tighten that nut, you strip the friction fit away, and so this shaft spins in this plastic housing, and then you have no way of getting the nut off the shaft to get the wheel off. And that's what happened to me. This is the good one. The other one, I literally had, as you can see here, I had to Dremel through the shaft, through the plastic, to get the wheel off. So let me show you the upgrades I've made to the gearbox. No changes to the electronics, the motor's the same, the gearing's the same, it should run the same. I've just added a couple of bearings, and obviously because I broke one of the drive hexes, I had to re-engineer how drive is given to the wheels. So let's have a look inside and see what's happened. This is stock on this side, this is my upgraded one with the brass drive shaft on this side. You see how this steel shaft went into this, drove the wheel, everything's great on this side, but this is not a bearing, this is just plastic rubbing on plastic, so not amazing. What we have on this side, I can show you here, is the upgraded system. So what we have is a square brass drive shaft that runs all the way end to end, no plastic conversion. What we do have is a 3D printed section here, which has a ball bearing on it under this brown tape. Now the reason it's got brown tape is because these are 11mm outer diameter bearings, and this drive shaft casing, A, isn't meant to have bearings in it, and C, is about 13mm, 13mm in diameter, and I don't have any of those bearings, so the easiest way to fix that is just to bodge some tape around it. So what actually happens now is this lovely ball bearing is what takes the force so that the drive shaft can spin much more freely than stock, and then this lip here just prevents the drive shaft from sliding in and out of the housing. And then obviously this hex piece of plastic on the end is what actually gives power to the wheel. Obviously it's got a nicely threaded end as well for an M3 bolt. So let's just quickly install this left-hand upgraded drive shaft in here. We can get rid of the old stock one. That can go over there. We now have the new drive shaft. It literally is a drop-in replacement, and that's it. It sits in here. There's a couple of little bits of tape there again just to add that extra padding to hold that bearing, because it is not the right size bearing, but this bit of plastic is not meant to have a bearing, so it is what it is. It works good enough for today. So that's in place there, that's in place there. You can see everything is nice and spins. The top will go on like that, and everything's working nicely. So this should be a slightly more efficient, with the bearings, stock drivetrain. So nothing has changed there. Now let's put this all back together. This is going to be a little bit slow, but this is just putting this drivetrain back together. We need to put there's 3 screws that hold the gearbox together. Now I'd really recommend you do this to any RC car you get. Just take it right back down to the basics. Every screw apart and put it back together. Then you really have an understanding for how these things work. Everything is known. You've held it. You've felt it. You've looked at each piece and gone, ah, that's interesting. That's how it goes. That's the fascinating part. you can always get it back together. Even film yourself taking it apart, then you know you can put it back together. Not that you're going to make a video out of it, but you know where each piece goes and you can put it back together, no worries at all if you filmed yourself taking it apart. And the keen-eyed among you will have noticed I put the diff in the wrong way around, so that was never going to work. Flip it around. That's much better. It's an interesting diff, actually. It's a very interesting diff because it has its teeth on the back. It means you can go motor into spur straight onto the diff pinion, and the diff pinion is offset, the gearbox is to the side, and then it pulls it back to a central diff instead of having a normal diff pinion is on the inside, so you'd have to move the motor off the center axis. So it's a really smart way of coming at the diff. I really like it. It's a very nice piece of design. We actually want to add a little bit of lubricant to that, a bit of grease. This grease is almost certainly from the 80s, so you know it's the good shit. None of this like fancy modern crap. Yeah, that should be nice in there. So we're going to leave that nice and lubricated. Thank you, Castrol. Very good. Right, now we've got the diff the right way around, and we've put the grease in. Let's get this assembled. Put that back together. Let's get the screws back in. That's looking really good. That's a lovely rear gearbox assembled and ready to go into the car. We're just going to place that there for now. What we need to look at now is the front end, and we're going to move backwards along. So let's get the steering all fixed up. The steering is really interesting in here. It's a very simple setup. There's nothing crazy going on. But let's just put it back together from its base components. We have these kind of front hubs. This one still has its steering arm on it, but as you can see, it's just one screw that holds that in place. But first we need to get the servo installed, which is this guy. He's going to sit in his slot there, no screws required. Very good. We're then going to install the hub and the steering arm here, which catches on the horn of the steering servo there. What have we got here? Oh, it's the press fit still. What I'm going to do is push out the crap, pull the press fit out. We're then going to slide a bolt all the way through, probably up from the bottom actually, make it a bit easier. That pops out the top. And we're just going to put a nut on the end of that, just for now. It's not permanent final fixture, but that'll mean that it's nice and secure, and I could just Loctite that in place and we wouldn't have to worry about it. I think I have another one here. Yeah, let's do that. Right, these are free. These drive shafts as well, press fit. It's going to be rubbish. We're going to have to work on that and upgrade those in the future. That goes through there. Just give these a cursory tighten, just against my finger. Just don't want them too tight. Okay, so they're not actually spinning, they're actually doing a great job. Why couldn't they have done that? Cool, so that's looking great. The steering is back together. The front end is assembled. See, what I did is I actually sliced the body just here. There was actually like one of these panel gaps there, so I just cut through a panel gap just so we could have this front end as a separate entity. We have the front end sorted and installed. Let's get the rear sorted and installed. This goes in here. This chassis piece goes in here. This is a really lovely mid-chassis section. This wire needs to get tucked just to the side of this. You don't want to pinch it in there. You want to just push it to the side. What we actually need to do is get the battery in first. The battery for this build lives underneath this part here. This all looks great here. This is all in place. This is up the front. See how that battery perfectly fits and is held down by this strap? It's like they designed this car for putting this battery pack in it. So look how easy that is for you to do at home. All you need is a Dremel and some wires. that's all going to screw in. Let's try and get this section kind of installed. This is all going to mount down like this. Oh yes, I was meant to do this first actually. These all kind of come together. I'm going to need to take one of these off. Let's take this one off. I think that was easier to get back on. These tabs just lock into place through that little hole there. Let's just hold this all in place. Like that. Then we can slide this back on like that. That holds everything together like that. This holds everything together like this. This now gets screwed in to place here. That's the rear assembly done. See our motor wires, we put a Dean's connector on the end of the motor just to make it easy to connect and disconnect from the battery, and it's easy, you can't get it confused because the battery is the same connector, so you can't plug the battery into the motor. It's not going to happen. Basically, we're kind of there. That's all it really is. It's not that complicated to put this back together from nothing. So let's get these screws in place. So that's nicely held in. Then these screws drop down. I don't know how long these need to be. They're not crazy. They're that long, they're the short ones, yeah. So that's really nice and rigid at the back there. We have a couple of screws just to put in at the back here. We're just going to put one in there just to kind of hold this back end together. One just drops in there. Kind of just vibing this back together now. There is no, you don't need to put all the screws in. You don't need to go crazy. Just put the ones in, like that screw there that just holds that together. It's great to put it in, but you really don't need it to run. It does kind of shore up this wing at the back, I suppose, a little bit, but it's not mission critical. Okay, the battery is trying to escape. Let's get the front built, and then we can actually put the top on and find a way to mount these electronics. I think they literally are just going to sit on top of these. I think that's literally all they need. Nothing fancy, nothing crazy, just, and there's no space for them to really go inside here. They're quite well held. They're not really going to rock around too much in there, and if they slide around, I don't really care. Same with this battery, like, look, it can move around. Maybe we just need to kind of like wedge it under there, but, you know, with something to stop it moving. But it really is not going anywhere. We'll just wedge it with something under there, I think, once we've got a bit of downward force on this here. Yeah, these are two more small screws. Fuck it, I'm getting rid of that. It's just driving me absolutely mad. So much better. And now look, we can just place this down, and it's not going to chew up the servo cable every time I place this thing. And we can put this in, which is going to be my battery clip. And look, it just goes. Oh my god, it works so well. What an amazing achievement. So my battery clip is just going to hold the battery down. It's just going to stop it going anywhere, so you don't get weird weight shifts while you're cornering. So now we've got this spring in there, really holding that battery in place. That's not going anywhere. That's this mid chassis installed. We could take out these sections here. Let's have a look. Yeah, it would let some air in. Is there anywhere for the air to get out the back though? There's not really anywhere for it to escape. Oh, yeah, they've kind of like boarded it up at the back there. I suppose we could take this part out at the back. That looks pretty good to me. I don't think there's anything, it's not going to change the world. But if we take these front bits out as well, then there's a path for the air to go through the car. Don't cut the battery off. That's looking great. Now we have these removed. Now we have these panels removed. When the Body goes on top. There's actual airflow into the front of the car, which is going to really help just cool down some electronics in the future. Okay, now this can go back together at the back. This can go in here. This can go on here. There we go. Cool, that's all in at the back nicely. Motor still drives. The battery's held in place nicely. Get that jumbo disc out of here. Get that out of here. Cool, so it's literally a case of wiring it up now. So, speed controller, we're going to kind of say goes there. Receiver, we're going to kind of say goes there. That, maybe. Don't really want to interfere with this metal thing, but whatever. What do we want to do, man? I don't care. Kind of should like tape them down, but can't be asked just yet. We're just going to do a little test. Let's plug the speed controller into that. If there's no wheels on it, we can see how it runs. Let's get that back in there. Cool, so we've plugged the battery in. Let's plug the steering servo in. That's going to go into channel 1. So that goes in there. Goes in there. Then the motor's going to go into there. That's all connected now. Let's turn on the handset. Steering. No throttle. Uh-oh. Ah. That's why we don't have any throttle. Because the wire fell off. Okay, so we need to solder this wire back on. Because it's not on there anymore. That's nicely grabbed. Shouldn't... If we're careful with that joint, it should be okay. It's something to be aware of with this car, I suppose. We could resolder that one while we're here, actually. The brown one's looking pretty haggard. Nicely in the middle of the solder blob. No complaints there. Good. Lots of pressure on these. These are really important screws, these back ones. There's a few critical screws on any vehicle like this that just hold everything together, and without them the whole thing just falls apart. And these two are some of those. These two and these two are really critical, and obviously the ones in the gearbox, but some are more critical than others. And as you're going to see with this, we're not going to put every screw back in. We're only going to put back in the screws that are necessary to hold the thing together. Because I don't like wasting my time. Right. So this slides around this. You can wiggle it back in. It is wiggleable. I mean, these wires almost do the job of holding the battery in place. They literally do the job of holding the battery in place. I think they're actually... I don't want to use those. I don't want to use those for that job. But that's literally as thick as it needs to be. It could just be a tiny piece of plastic. Use a piece of plastic that you have lying around. And I think that will just... That just wedges that. Oh, it needs a fraction more. Let's bend it in half. Whack it with a hammer. Like that. Now it's got a bit of spring to it. Where's that underneath? That'll be grand. Screwing the battery in is a bit insane, but I don't have any other projects for this battery to be in, so it doesn't actually bother me that it's screwed in. That's holding it nicely in place. We don't need that piece of metal, because that could short out against something, you know? Having a piece of plastic there just does the job. Let's plug the motor in. Oh yeah, it wants control, doesn't it? Okay, so that means we have drive from the battery to the motor, we have steering. Let's see what we get. So this dial here controls how much throttle you have available. Now, if you see, if I pull through full throttle on and then turn this dial up, you'll see the speed increase. So this is kind of like a top speed limiter dial. So let's see what happens. Great, so we have all the electronics inside. Let's just get the final parts of the body back on, get it all looking as good as it can. And there you have it. The car is put back together with the upgraded battery up to 8.4 volts. Listen to this guy. Way faster. Let's get outside and see how this thing runs. In the business you'd call that a severe incident. 14 miles an hour. Beautiful.